defect of vision, presbyopia. Presbyopia is a defect of vision in which the eye lens loses its ability of accommodation because of the age. That means when people grow older, their near point recedes away. That means people will feel difficult to see objects which are nearby distances. That is called presbyopia, and it is also called as old age hypermetropia. Okay, but in some cases people will suffer from both myopia and hypermetropia. What does it mean? That means people will feel difficult to see nearby objects as well as they feel difficult to see far objects, both. What is the cause of these things? Two things are the reasons for this. First one is weakening of ciliary muscles because of the old age. And other one, the diminishing of flexibility of eye lens. You know that eye lens will flexible so that it adjusts its focal length, right? If eye lens loses its ability of flexibility, then these problems may come. Now, how can this defect can be corrected? We know that the hypermetropia can be corrected by using convex lens. Okay, but if the case is both myopia and hypermetropia, to correct this we need a bifocal lens. What does mean bifocal lens? Bifocal lens is a lens which is the combination of both convex and concave lenses. A lens consists of the lower portion consists of a convex lens and upper portion of lens consists of concave lens. That means if a person suffering from presbyopia uses this bifocal lens, if he has to read something, he need to see from the lower portion of that lens to correct hypermetropia, and to see a far object he need to see through the upper portion of the lens to correct myopia. Like that, this defect can be corrected. Have you ever seen any prescription given by an eye doctor? After testing a defect of vision, an eye doctor prescribes a corrective lens in terms of the power of the lens. Now let us try to understand the power of the lens. For that, let us consider a convex and a concave lenses. And we know a light ray parallel to the principal axis, after refraction it get converged and meet the principal axis. Okay, and from instead of going in a straight line, it get converged with some angle. It is that called degree of convergence. That degree of convergence depends on the power of this lens. If power of the lens is more, then degree of convergence will be more. And if power is less, then degree of convergence will be less and light ray will go and intersect the principal axis somewhere far from the lens. The same can be applied here for concave lens also. Like that, instead of going in a straight line, light ray when parallel to the principal axis, after refraction from the concave lens, it appears to diverge from a point. This angle is called degree of divergence. And again, degree of divergence depends on the power of this lens. If power of this concave lens is more, degree of divergence will be more. And if power of the concave lens is less, the degree of divergence also will be less. Now let us define this power of the lens. Power of the lens is the degree of convergence or divergence of a light ray achieved by a lens. Once again, I am repeating it. Power of the lens is the degree of convergence and divergence of a light ray achieved by a lens. In other words, we also can define power as power is the reciprocal of focal length. Power is the reciprocal of focal length. If focal length is considered in meters, then the formula will be this. If power is focal length is taken in centimeters, then formula would be this. If focal length is taken in centimeters, then formula will be 100 by f. Okay, and power is measured in diopters, that is unit of power is diopter and is represented by a letter capital D. Let us try to understand power with a small example. In a question it is asked like that: a person suffering from an eye defect and doctor prescribed him to use a lens of power 2 diopters. Power of 2 diopters. Now he is asking to find the focal length of the lens and the nature of the lens and the defect of vision. What kind of defect of vision he is suffering from? So first let us start with finding the focal length of the lens. We already learned power is the reciprocal of focal length. So from that, focal length is equal to 1 by p. If you want the answer in meters, just you can use this formula, that is 1 by 2, you will get, what is it, 0.5 meters. If you want the answer, that is focal length in centimeters, then you can use the formula 100 by f. There you will get 50 centimeters. Here, see, as the focal length you got is a positive, that means the lens nature is convex. And you also know that convex lens is used for the defect of hypermetropia.
Here we are observing normal lens. When parallel beam of light comes, normal eye lens forms an image on retina. You can see here the light rays are converging and intersecting at retina, so image forms on retina. See here, you are observing a myopic eye. It forms an image before the retina. For the correction, we are using a concave lens. See, when a concave lens placed before the eye lens, then the light rays are intersecting on retina and image will form on retina. This is how myopia will be corrected. You can see an hypermetropic eye. There, the image forms beyond retina. See, the light rays are intersecting beyond retina. Now, to correct this defect, we are using a corrective lens, that is a convex lens. When the convex lens is placed in front of the eye lens, see what happens. Yes, the light rays after refraction are intersecting on retina to form a clear image. This is how hypermetropia can be corrected.